In this video, we're going to learn about one more type of special right triangle, and that's a 30, 60, 90 right triangle. So where the 30, 60, 90 right triangle comes from is if you start with an equilateral triangle, where all three sides are equal and all three angles are equal, meaning each of the three angles has to be 60. And if you draw in the altitude, the perpendicular bisector, the median, or the angle bisector, so going from the vertex to the opposite side, if you draw that in, that serves as the altitude, angle bisector, perpendicular bisector, which means that it's going to divide that 60-degree angle into two equal parts, so 30 and 30. It's also going to divide this side in half. So this side right here will always be half of one of the equal sides of this equilateral triangle. So that's where the 30, 60, 90 triangle comes from. So you take an equilateral triangle, you use the altitude, the angle bisector, median, or perpendicular bisector, and you'll have a 30, 60, 90 right triangle. So the first relationship that you need to know is that this shorter leg, so I'm going to call this SL for shorter leg, that shorter leg will always be half of the hypotenuse. And again, the reason for that being the hypotenuse is one of those equilateral triangle sides. And if you're dividing, if that altitude is serving as the perpendicular bisector or the median, it's splitting one of those sides into two equal parts. So that's why this relationship between the shorter leg to get to the hypotenuse, it's always times 2, or the shorter leg is always half of the hypotenuse. So the question becomes, how do you know what this longer leg has to be? So I'm going to call that the longer leg. So let me just put b in here, and let's use Pythagorean theorem to solve for it. So if I have x squared plus b squared equals 2x squared, notice I have to put the 2x in parentheses. I'm squaring each piece. So I end up with x squared plus b squared equals 4x squared. Subtract the x squared from both sides, you get b squared equals 3x squared. And then you square root both sides. B is equal to the square root of 3 times x. So that means the relationship here, instead of b, I'm going to write the square root of 3 times x. So the relationship between the shorter side to get to the longer leg is going to be to multiply by root 3. So the easiest way to actually remember the relationship here is, one, you could go through this whole process that we just talked about, but two is to think about, if you remember the ratio, so the ratio here between the sides is a 1 to radical 3 to 2 ratio. And when you look at this, the smallest angle is 30 degrees, so that means the shortest side has to be across from that. So that's what side corresponds to the 1, the short leg. Then the next biggest angle is 60. Across from that is going to be your longer leg, which is times radical 3. And then the largest side is across from the 90-degree angle, which is the hypotenuse, which is times 2. And when you think about the numbers here, radical 3, just to keep in mind, is smaller than 2. So that's why the radical 3 is going with that longer leg, because that's the medium length side. So that's kind of just another hint to remind you which way it goes. But the short leg will always be half of the hypotenuse. It's kind of easy to remember just because it comes from an equilateral triangle where the hypotenuse is one of the sides. And when you draw in the altitude or the perpendicular bisector, divides that other side into two equal parts. So a couple things here to remember. Basically what I just said, we have our two formulas and we have our ratio. So that means our formula here, the hypotenuse is always 2 times the shorter leg, and the longer leg is always going to be radical 3 times the shorter leg. So notice both formulas use the shorter leg. So when solving problems, I'm going to say always start with the shorter leg. So that's something you're going to want to remember. Always start with that shorter leg, because both formulas require you to know that. So that's going to always be our first goal, is let's find the length of the shorter leg. So if I look at part A here, the length of the shorter leg is where I want to start. So you start at your 30-degree angle. We go across from that. This is going to be the shorter leg. So this is the shorter leg. This is going to be your longer leg, and this is the hypotenuse. Now, again, because I have 30 degrees here and a 90, I automatically know that this has to be 60, because 180 minus the 90 minus the 30 leaves me with 60. So right away I have a 30, 60, 90 triangle. So all of these ratios apply. So we know that if we start with the shorter leg, to get to the longer leg, it's going to be times radical 3. And to get to the hypotenuse, it's going to be times 2. So you can write out these formulas and plug in, or you can kind of label your picture, which is kind of the same thing as doing the formula. It's just more of a visual way. So regardless, we always need to get that shorter leg. So when you look at this, we have the longer leg, and we're trying to find the shorter leg. So let's start with using that formula or that relationship there. So the longer leg is equal to radical 3 times the shorter leg. So 5 equals radical 3 times x. So solve, we end up with 5 over radical 3 equals x. So instead of rationalizing all of these, I'm just going to leave these with the radical in the denominator. But remember, if I wanted to rationalize, I would be multiplying both by radical 3 over radical 3. So then it would end up giving you an answer without a radical in the denominator. But for this, it's an equivalent answer. I'm going to leave it like this. So that's one way. Use your formula. The other way is just to look and say, okay, well, if it's times radical 3 to get to the longer leg, I have to go backwards. So 5 divided by radical 3 gives me the short leg. And then once you have the short leg, well, it's just times 2 to get to the hypotenuse. So 5 over radical 3 times 2 is going to give you 10 over radical 3. You just multiply the numbers up top. This is really like saying 2 over 1. Or you write it out in the formula. So the formula is hypotenuse equals 2 times the shorter leg. So the hypotenuse is hypotenuse equals 2 times the shorter leg, which is 5 over radical 3. And again, when you multiply these out, this is just 2 over 1, it's going to be 10 over radical 3. And again, I'm just going to leave that, not worry about rationalizing it. So using the formula or using your labels on your diagram will get you to those answers. So I'm going to allow you to kind of pick if you want to use the formula or if you want to use the diagram, but make sure that you have some kind of work to represent that you know the ratios. So next question here, we have the 60 and the 90, so that means this angle's 30, which means this is my short leg. This is where I'm starting. So to get to the longer leg, it's going to be times radical 3. To get to the hypotenuse, it's double, so times 2. So again, if you're going to use your formulas, you want to use the formula that compares the longer leg to the shorter leg. So longer leg equals radical 3 times the shorter leg because we were given the longer leg. So plug in. So we have the longer leg is the square root of 15. Radical 3 times x. So divide. So when I divide here, I'm going to write this one out. When you divide, this is the same thing as saying the square root of 15 divided by 3, which ends up being square root of 5. So that will just be square root of 5 because remember when it's radicals, you're allowed to just divide the numbers underneath. And then when I go to do, so now I know that this is square root of 5. So now I can just multiply that by 2 to get to the hypotenuse. Shorter leg times 2 gives me the hypotenuse. So this is just going to be 2 root 5. Or write out your formula. Hypotenuse equals 2 times short leg. Hypotenuse equals 2 times root 5. So you get 2 root 5. And then the last question here is now combining both types of triangles that you've seen. So we have a 30, 60, 90 triangle. We also have a 45, 45 triangle, or 45, 45, 90 triangle, I should say. So this triangle right here is isosceles. We have the 2 equal sides. So really I know that this is also x, whatever I get. And because I have the 4 root 2 on this 45, 45, 90 triangle, I'm going to start with that. So if you remember the relationship from yesterday, is that the hypotenuse in a 45, 45, 90 triangle, the hypotenuse is equal to radical 2 times the leg. So that means I take the leg, I multiply that by radical 2. That's how I get to the hypotenuse. So if you're undoing that, you're going backwards. You're taking 4 root 2 and dividing by radical 2. So the radical 2's cancel. So that means this is 4. You could also plug in over here. So 4 root 2 equals root 2 times the leg. So divide both sides by root 2. So this is just kind of showing more of the steps here. That's how I get 4 for that. Let me actually switch this to say x. So that's going to be 4. And then we look at our next type of triangle, which is the 30, 60, 90. Starting at the short leg, to get to the long leg, it's going to be times root 3. To get to the hypotenuse, it's times 2. So that means we have, if we want to find y, so for the 30, 60, 90 triangle, the long leg is going to be root 3 times the short leg, or you could just take 4 and multiply it by root 3, so 4 root 3. Or you actually fill in the formula here, so y is equal to root 3 times 4, so 4 root 3. And then your hypotenuse is equal to 2 times the short leg, so 4 times 2 gives me 8. So if you're filling in your formula, z is equal to 2 times the short leg, so z equals 8. Again, as long as you show the numbers on the picture here, I'm okay with you not necessarily writing some of this stuff out, because some of it, it's easy enough just to see here on your picture and you see the ratio. So now you have both types of special right triangles. Remember, you can still use SOHCAHTOA for these types of problems, but the question here asks for exact answers. So the only way to get exact answers here is to be using these ratios, unless for some reason when you're doing your sine, cosine, or tangent and the numbers come out to be whole numbers. But if it says exact answers, it means think about your special right triangles. These are supposed to be shortcuts. In their special cases, so they don't work for every problem, only when you have 45, 45, 90 or 30, 60, 90 right triangle. So go ahead, take your key ideas, write them down, and then check your understanding problems, and we will talk about those in class tomorrow.